Okay, here are the notes. Copy them down. I'm gonna go a little quicker. And again, well, you have a video here, so you can watch it as many times as needed. You can pause it, you can rewind it. This is the notes on solving radical equations. Now I know radical, this word radical sounds like the word rational, kind of very similar sounding, but when the rational or ratio means a fraction, right? When you have like a numerator and a denominator. Radical refers to like when you have roots, right? We don't always say square roots, but they can be square roots, but they can be cubed roots, they can be fourth roots. Luckily, I think we're only going to look at these with the square roots. Okay, so you're going to be solving these problems like this. This lesson should be easy. Let's start with the very first one here. 8 minus x, the square root of 8 minus x, right? It's going to say solve. It's going to say solve. The square root of 8 minus x is equal to the square root of 11 minus 2b. Where am I getting a b from? X. Okay. Well, the good thing about this, remember, we have an equation. We could do anything we want to one side as long as we do the same thing to the other side. Since they both have a square root like this, well, guess what? We're just going to square both sides, right? We're going to square both sides, and that's going to undo the radical. So these are the easiest ones you're going to encounter. If it was a cubed root here, well, then you raise it to the power of 3. If it was a fifth root, you raise it to the power of 5. Anyways, the square and the root will cancel each other out, right? So you're pretty much left with this 8 minus x equals 11 minus 2x, and then you just solve for x. This is where students begin to start, being careless here, where you kind of just be careful, don't make silly mistakes. So move all the variables to one side, move all the numbers to the other side. So I'm going to move the -2 this way, all the variables on the left, all the numbers on the right. That'll give me 2x positive minus x equals 11 minus 8. Okay, I'm going to get the answer. X equals 3. 3. Okay, well, that's the easy one. You're not going to see these easy ones. They're going to get much more complicated. Look at number 2 now. Number 2 is going to be something like this. 4 is equal to the square root of m plus 9. So you're not just going to have 2 square roots. You're just going to have a square root on one side, or a radical. I shouldn't say a square root. It's not always a square root. A radical on one side. Now, listen to this part. This is how you want your problem to be, essentially, because it's not going to be given to you like this. And what do I mean by this is what I want the problem, how you want the problem to be. You want to have the part that has the radical alone on one side. It has to be alone on one side. I can't have this square root of m plus 9 and then like a plus 6 over here, or I can't have a number in front multiplying. You have to get rid of that first and just have the radical alone on one side and the number on the other side. That's what you want. Okay? It's not going to be given to you like that. So this one is kind of easy, so it's already ready for you to go. Why do we want this radical alone on one side? I don't want another number here. I don't want another number here. Why? Because now here you're able to what? Square both sides. Right? That's how I'm going to undo this square root, is to square it. If it was a cubed root, you'd raise it to the power of 3. And if you square this one, you got to square this one. Whatever you do to one side, you do to the other side. And this will give you what? M plus 9 is equal to 4 squared is 16. And then the solving is easy, right? You're going to get, right, minus 9 minus 9. M is equal to 7. Right, 16 minus 9. That positive 9 moves that way. It's negative. Okay. That one's not too bad, right? Okay, number 3. The square root of 72 minus n plus 9 is equal to 17. See, now they're looking at a little bit more intimidating, right? Again, what did I just mention a little while ago on the previous problem? The part that has the radical has to be alone on one side. I don't want this plus 9. You don't want to square both sides like this right now. Okay, so we're going to move this positive 9 to that side. So that's going to be the square root of 72 minus n is equal to 17 take away 9 is 8. Yeah, 8. See, now this is now ready for me to be able to undo the radical. How do I undo this radical, the 72 minus n? Well, again, it's only a square root, so I square it. If it was a cube root, you'd cube it. And if I square everything on this side, I got to square everything on this side. This frees up. You got 72 minus n equals 64, right? 8 squared, 64. I don't want my I don't want this to be negative, so I'm actually going to move this to that side and move this to this side. So that's 72 take away 64 equals positive n. See, I want that n, the variable, to be positive. You could have left it there, moved that there, but then you had to divide by 1. Anyways, I think you get the answer 8. 72 take away 64, 8. All right, so you guys can see that's not that bad. Well, hold on, it's going to get more complicated. Here we go. We're going to build up, and they're going to start right here. Look at number 4. Here's where we take it to the next level. We'll do an easy one right here on number 4. X is equal to the square root of 110 minus x. Oh, it doesn't look too bad. I already have the radical alone on one side. I am ready to square both sides, right? But what are you going to realize right away? When I square both sides, see, now this is a quadratic. See, now you're going to get x squared is equal to what? 110 minus x. See, back over here, when you did this, it was just like a simple algebra 1 equation you had to finish. Now what you're going to see these here is when you clear the radical, right, when you square both sides, now see, now it's quadratic. It's quadratic because of the x squared. Quadratic. Anybody remember how to solve quadratics? When it's x squared, that's when you want to move everything to one side and make it equal to 0. So I want to keep that x squared positive. I want to keep the x squared positive. I got to move these to that side. So that's going to be x squared plus x, right? Let's put this in order. X squared plus x minus 110 equals 0, right? We got to set this equal to 0. And this is where we got to look at this. If you remember quadratics, you try to factor it. Remember, factor it. Try to find these two. What are they called? Binomials? Yeah. These two binomials where it multiplies to this 110. Ugh, how do I remember how to do that? Anybody remember how to do that? Let's see. Let me just review this real fast. How am I going to do x squared minus, what was it? Oh no, plus x minus 110 equals 0. For those of you that were with me algebra 2 and we learned how to factor, right? What you got to do is you got to look at this last number and find all the factors of 110. Factors of 110. If you don't remember factoring, you better go to YouTube or email me and I can put something up on Delta Math for factoring. Factors of 110 are 1 times 110, 2 times 55, 3. Does 3 go into 110? Let's see, 3, no. Does 4 go into 110? 4. 4 times 2, I think it does. I don't have a calculator, I should. Let me use my phone. How do I know if it goes? You divide it, right? 110 divided by 4. Oh, no, it doesn't. It gives you a decimal. 5. 110 divided by 5. I know that one works. 110 divided by 5. 22. And then you're going to keep going, and then you're going to keep going. But I'm going to tell you which one it is. It's going to be 10 times 11. Right? 10 times 11 is 110. And since it's a minus, those of you that remember, since this is a negative, right? This number is telling you to find the factors. This one is telling you either to add or subtract. Well, takeaway is subtract. Right? Now, if I look at these factors that this list that I just populated, all these that multiply to 110, which one of these sets of numbers subtract to give you this? This is a positive 1x, right? Everybody agree this is x squared plus 1x minus 110? Yeah, that's a 1. That's a 1. Which of these sets of numbers can I subtract to get a 1? While 110 take away 1 is not it. Well, obviously, 55 take away 2 is 53. 22 take away 5, 17. Winner, winner right here. 11 take away 10 is 1. What does that tell you? That tells you that this is going to factor out with a x, right? This, to get the first leading term, is x times x, x squared. And these two numbers that are going to be here are 10 and 11. And then it's a negative. Does that mean that they're both negative? Nope. Does that mean that they're both positive? Nope. That means that one's positive and one's negative. Which one has to be positive? Which one's going to be negative? This one's going to be positive. This one's going to be negative, right? Because when I add these, it gives me a positive 1. Some of us are going to have to probably review factoring. Or if you didn't learn it too well, there you go. Okay, so these will factor when you get a quadratic. And then finally, right, this one you're going to put x minus 10. This parentheses, you put it equal to 0 and solve it. This x plus 11, you also put it equal to 0 and solve it. So this one's x equals positive 10. And this one's going to give you x equals negative 11. Okay. Now what you actually have to do is actually go back and check. You have to check which one of these two answers work, because sometimes only one of them works. Sometimes they both work, but sometimes only one of them works. So going back, remember you got to check. Check if solutions are valid. And how do you check? You got to go back to our original problem. What was our original problem? This one. X is equal to the square root of 110 take away x. I'm going to check this first one. If x equals 10. If x equals 10, I'm going to put a 10 here. 10 is equal to 110 take away 10, right? I'm checking the first one here. Everywhere there's an x, I'm putting a 10. And this has to give me a true statement. Is 10 equal to the square root of 110 take away 10? When I do 110 take away 10, that's 100. Is 10 equal to the square root of 100? Yeah. 10 is equal to 10. Yeah, the square root of 100 is 10. So this one's good. This one's good. 10 works. But how about negative 11? You think negative 11 is going to work? Let me check that one over here. Again, we write the problem again. Is negative 11 going to work? Let's see. Negative 11 is equal to 110 take away a negative 11. Is that going to work? Let's see. Negative 11 is equal to, that's going to be 110 plus 11, right? That's going to be the square root of 121. Does that equal to negative 11? No. It actually equals to positive 11. Positive 11 is 121. It doesn't equal to negative 11. So guess what? We cannot accept this answer. You won't see this answer on the key. When you get two answers, that's why you'll only see one of them. Even though we did get two answers, only this one's the valid one. All right, let's continue. I got two more I'm gonna go over quickly. I know this video is running a little bit longer, but instead of making two videos, I'm just gonna keep going. Okay, next one. This is number 5. The square root of 6a plus 15 is equal to a plus 4. All right, now they're getting a little bit more challenging. Well, I already got this piece with the square root alone on one side, right? That's what you want. Make sure that that's alone on one side. And now I got this over here. Oh, this one's different. Okay, you do have to square both sides, right? But now when you square both sides here, you got to square both of it, like the whole thing like this. So this will free up and you'll just get 6a plus 15. But on this side, a plus 4 squared means what? It means a plus 4 times another a plus 4. So that's going to be 6a plus 15 equals, how do you multiply these? You got to FOIL it out like this or do the box method. All right. And long story short, when you do this, which again you should already know, that should be a squared plus 8a plus 16. Okay. So now I got all this. But the main thing I noticed when I get to this point is that I have a variable that's squared. When you see a squared like this, that means you're dealing with one of these quadratics. It's a quadratic. Ugh. Those are the ones that are going to be tougher. Those are the ones you're going to have to factor. When it's quadratic, that means you got to move everything to this side, to the side where the a squared is positive. So let me keep this over here. A squared plus 8a plus 16. And I got the 6a plus 15. But I got to move these to this side, right? I'm going to move that over there. I'm going to move that over there. When this 6a goes over there, this is positive 6a. Isn't it going to be negative 6a? I'm going to put it right there because those are like terms. And that's positive 15. But when I throw it to the other side, it's negative 15. You're going to have 0 on this side. What's going to be left? You're going to have a squared plus 2a. A squared plus 2a plus 1. 16 take away 15 is 1. And I'm telling you right now, the problems that I'm going to give you, they will be factorable. You can factor this. Geesh, I wonder what two numbers multiply to 1 and add up to a 2. Well, it's going to be 1 times 1, right? So this is going to be what? A plus 1, a plus 1, like that. And you're really going to get the same answer twice, right? So we'll just solve one of them, right? Because they're exactly the same. How do you solve these? You set it equal to 0 and you set this one equal to 0, but they're both going to give me the same answer, right? I'm supposed to set this one equal to 0 and this one equal to 0, but we're going to get the answer on the same answer on both. And then, yeah, you can go back and check it, but this one's going to work. The answer is just a is equal to -1. Okay, let me do one last one real quick. Again, you can see they're increasing in rigor. And let's do that one, number 6. Okay, p minus 3, it'll probably be similar to this one that I just did. 3p minus 9. Okay, I can square both sides. I can square both sides, right? Because this radical is already alone on one side. That's going to be what? P minus 3 times p minus 3 equals. And then this square root and the square cancel each other out. This side is ready to go. This side you got to do this product here to FOIL this out or do the box method. I'm just going to tell you what it is. This is p squared minus 6p plus 9 is equal to 3p minus 9. Okay, do I have a quadratic? Yes, you do. It's right here, the square. That means everything has to be moved over to this side where this one is positive. So if I move that over there, that's going to be minus 3p. If I move that over there, it's going to be plus 9. So equals 0, right? I got nothing left on this side. What's left on this side? P squared minus 9p plus 18. And then you got to look at your factors of 18. Which factors of 18 can give you a 9? Well, let's see. I'm just going to do it real quick over here. 1 times 18, 2 times 9, 3 times 6. Which ones can give you a 9 when you add them? 6 and 3. But because it's negative, it's supposed to be p minus 6, p minus 3. And then how do you solve this? Well, this one you put p minus 6, set it equal to 0. This one's going to be p minus 3, set it equal to 0. Here you're going to get this answer, p is equal to 6. Here you're going to get this answer, p is equal to 3. Okay, so remember, you got to go back and actually check this one, put this back up in here, and it should hold a true statement. It should be equal. And then you also got to check this one and substitute it in here, and it should also hold a true statement. I'm going to tell you right now, both of them are going to work. Both of them work, so they're both correct. Okay, but that's how you do it. All right, good luck with this assignment. That's it.